So let's begin by working a few problems out of 5.7. So the first couple problems are just reminding us how inverse trig functions work. Sometimes they're written as, for example, in this problem, we're taking inverse cosine of 1. Another way of writing that is arc cosine of 1. These two things are synonymous. Often in Math 113 trig, we use the inverse notation, but the arc trig function means the same exact thing as the inverse. So in this question, they ask us to evaluate this without using a calculator. So let's remind ourselves what this means. When we take regular cosine of something, the input is an angle, the output is a ratio. When we do the arc cosine, it's reversed. This is a ratio, and it's asking us for what angle do we have the ratio 1. So remember, on the unit circle, cosine is the x-coordinate. So where on the unit circle is the x-coordinate equal to 1? Well, the x-coordinate would be 1 there. That point is 1, 0. To the right, 1, up and down, none. So the angle for which cosine is 1, that angle is 0 degrees, or they're going to want it in radians, which is also 0 radians. So that's what they were looking for here. But typically, you're going to be able to use a calculator to do this. If we took out a calculator and we wanted to calculate arc cosine of 1, we would pick our mode, which is normally going to be radians. We would put in our input and say take inverse cosine of that, and it gives us 0, which is what we got from the unit circle. Here they give us an equation that is nothing more than a relationship between x and y, and they ask us to find tangent y. I believe they also give us a picture with this, but let's look at y equals arc cosine x, and then find tangent y. Well, we know that y has to be an angle. How do we know that? Because when we take sine, cosine, tangent, we're taking those with respect to angles, and our answer is a ratio. For our arc functions, those are backwards. This is our ratio. This is our angle. So there exists some triangle. Notice they say y is between 0 and pi over 2, also 90 degrees. So there's some triangle that has an angle that we call y, and the ratio of cosine is x, which x, written as a fraction, is x over 1. So cosine is adjacent over hypotenuse. So in terms of cosine, the adjacent side is x, the hypotenuse is 1. So this equation they give us just establishes a relationship from an angle to a ratio, and we can find out the other side as well. So in this triangle, another way of saying that equation, instead of arc cosine of x is y, we could say cosine of y is x. From y, cosine is x over 1, or just x. So if we want to find that other side, we have a right triangle. We can find that using the Pythagorean theorem. So x squared plus the side we're looking for squared equals the hypotenuse squared. If we're solving for that unknown side, subtract x squared from both sides. So 1 minus x squared. Get rid of the square by taking the square root of both sides. So that unknown side is the square root of 1 minus x squared. So that just gives us an expression for this other side, knowing the adjacent and the hypotenuse side. So if we want to find tangent with respect to that angle, tangent is opposite over adjacent. So from y, the opposite side is the square root of 1 minus x squared. The adjacent side is x. So this is just using our inverse trig functions and relationships to evaluate this particular problem. This problem can be done similarly. We could write an equation. We could draw a triangle and write this out. Another way to handle this is to keep in mind that if we have a function and its inverse, and we do the composition, those undo each other. How's that going to help me in any way? If we take the tangent of the left, tangent of the right, and arctangent undo each other, and tangent of -1, if we put a -1 in, well, we're going to get a decimal for that, so let's not do that yet. Let's just leave that tangent of -1. That's in radians. So to get x by itself, add 4 to both sides. 4x equals tangent of -1 plus 4. And then you get x, divide both sides by 4. So x is whatever we get when we do that. So we could take, we don't want inverses, but we want to take tangent of -1, add 4 to it, plus 4, and then divide that by 4. So about 0.6106. If I type that in my calculator correctly. And not necessarily the only way to do that, but that's one way to go about doing that. Okay, when we get to this problem, they're actually asking us to take the derivative. They want to find y prime. So in order to do that, we need to interject some new derivatives that we've not covered yet. If you watched the video for this section, then you should have covered them. But if we're taking the derivative of arc sine u, and some of these I know by memory, I'm not, some of these I sometimes forget. The derivative of arc sine is u prime over the square root of 1 minus u squared. The derivative of arc cosine is very similar to that. The derivative to arc cosine is minus u prime over the square root of 1 minus u squared. So the only difference is that SIGN sign, positive or negative. If we have arc tangent, and we want to take the derivative of it, u prime goes on top, whatever we're taking arctangent of, and on bottom 1 plus u squared. No square root, and notice it's a plus instead of a minus. If we're taking the derivative of arc cotangent of u, these two have a similar relationship as these, so the derivative is still u prime over 1 plus u squared, but we have a negative there instead of a positive. And then for secant and cosecant, the derivative of arc secant u is u prime over the absolute value of u times the square root of u squared minus 1. So notice the u squared comes first, and then the number, where on these we had 1 and then u squared. 1 and then u squared. So arc cosecant is going to be similar to that. The derivative of arc cosecant is minus u prime over the absolute value of u times the square root of u squared minus 1. So 6 new derivatives. So once we get through these derivatives, we can pretty much take the derivative of all elementary functions. And what we mean by elementary functions are polynomials, rational functions, radical functions, exponentials, trig functions, logarithmic functions, exponentials, things like that. So with these rules, we can take most derivatives. So if we want to take derivative of arc sine, this is u. So let's get rid of that for now. So if u is x over 2, or we could call that 1/2 times x, then u prime is 1/2 times the derivative of x, which is 1. So for the first sine is u prime, so 1/2 over the square root of 1 minus u squared. And we have 4 out front. Then we have to subtract whatever we get when we take that derivative. Now when we take that derivative, that's a little bit more complicated because that's a product. We have a function or a variable times something with a variable. So how do we go about doing that? So product rule, remember, is u prime v plus u v prime. So we need to know the derivative of x. So this is a whole nother u and v. So for this u is x, u prime is 1. Here, v is the square root of 4 minus x squared, or we could say v is 4 minus x squared to the 1/2 power. So v prime is a derivative of that. And what rule do we have to use? We have to use the chain rule because we have more than just x to a power. So we bring our power down, 4 minus x squared to the 1 less power, but we have to multiply times the derivative of the inside. The derivative of the inside is negative 2x. That 2 and that 2 cancel. If we simplify that, we have a minus x on top. If we move this negative exponent to the bottom and change it back to a radical, we have the square root of 4 minus x squared on bottom. So if we fill in our product rule for this particular part, it's u prime, the derivative of x, times v, plus u, which is x, times v prime, which is negative x over the square root of 4 minus x squared. Now, notice we're subtracting that, so if we want to, we can move that minus down there. We can simplify this a little bit. Notice on top we have 4, 1/2, which what's 4 times 1/2? Well, half of 4 is 2. And then on bottom, we have the square root of 1 minus, if we square that fraction, we get x squared over 4. Then minus that parenthesis. So if we subtract that, we have minus that square root. If we subtract this, notice we have positive times negative. That's a negative x squared. If we distribute this negative to here, minus a negative will make that a plus x squared over square root of 4 minus x squared. For this fraction, I'm going to work this out on the side. If we have 2 over the square root of 1 minus x squared over 4, let's get a common denominator on the inside. So that common denominator is going to be 4. So if we multiply the bottom by 4, we're going to multiply the top by 4. Notice 4 over 4 is 1. So under that radical, we have 4 minus x squared over 4. If we have a fraction, we can take the square root of the top and bottom separately. Well, we can't take the square root of the top because we have a subtraction in the middle. But the square root of the bottom is 2. Well, we can keep, change, flip. We can take that numerator, and instead of dividing by that fraction, we can multiply by the reciprocal. So that gives us 4 over the square root of 4 minus x squared. So that's what this first simplifies to. 4 over the square root of 4 minus x squared. Then notice we're adding a fraction with that same denominator, so we can add the numerators, keep that common denominator, and then we have minus that. Now, if you want to, you could get a common denominator here. If this term doesn't have a denominator, it's got an understood 1. So our common denominator is going to be the square root of 4 minus x squared. So we'd multiply top and bottom by that square root. So for this term, when we multiply those numerators, notice those are the same thing. So essentially we have a square root that we're squaring. So those cancel, leaving us what's underneath. So we're going to be subtracting 4 minus x squared, which is the numerator of the square root of 4 minus x squared. Now our two fractions have the same denominators. So lastly, we have the same denominators. We can put these fractions together. We have a 4 and a minus 4. 4 minus 4 cancels. We have an x squared minus a negative x squared. Well, minus a negative makes a positive. So an x squared and another x squared makes that 2x squared. So that was messy. But I did want to work through that so you could see how that algebra works in simplifying that. But a couple key parts is, how do you take the derivative of arc sine? We use that formula. How do we take the derivative of this term? That's a product of things with variables, so we have to use the product rule to take that derivative. And this part, we have to use the chain rule to take the derivative of that radical. Let's do one more problem from this section. So it asks us to find any relative extrema of this function. And remember, relative extrema are maximums or minimums, points that are higher than the surrounding points or lower. Now remember, where they occur is at critical points, and those are where the first derivative is 0. Occasionally where the first derivative is undefined, but typically where the first derivative is 0. So we need to find the first derivative for this particular function. So f prime is, we have two terms, so the derivative of arcsecant, that's one of our new formulas, so if we call that u, the derivative of arcsecant is u prime, which is 1, over the absolute value of u times the square root of u squared minus 1, and then minus the derivative of the second term. So that's our derivative. Now we need to find out where is this derivative equal to 0. So we can multiply, or we can add 8 to both sides. If we want to, we can cross multiply, or you could say multiply both sides by the absolute value of x times the square root. Absolute value of x times the square root. So those cancel, so we get 1 equals 8 times the absolute value of x over the square root of x squared minus 1. So since we have a square root here, let's leave the square root here, and let's move these two terms to the other side. Because when we have equations that have square roots in them, to make the square roots go away, we isolate the square root and then square both sides. So those cancel. So we're left with 1 over 8 times the absolute value of x equals the square root of x squared minus 1. So if we want to make the square root go away, we square the left and we square the right. So those cancel, so that gives us x squared minus 1. On the other side, when we have a fraction, we square the numerator and square the denominator. So 8 squared is 64. If x is positive, when we square it, it will be positive. If x is negative, when we square it, it will be positive. So we can drop the absolute value and call that x squared. That's going to be positive regardless of whether x is positive or negative. So we don't have to have that absolute value. To get rid of our fraction, multiply both sides by 64x squared. So those cancel. So on the right, we get 64x to the fourth minus 64x squared. That's not linear, so get a 0 on one side. And one thing that makes this hard is this doesn't factor. This doesn't factor directly. And it's not quadratic. But we can make a substitution and turn it into a quadratic. If we replace x squared with u, then x to the fourth would in turn be u squared. And that is quadratic. So u, which is really x squared, is the opposite of b plus or minus the square root of b squared minus 4 times a times c over 2 times a. So if we solve that quadratic equation, that gives us u, which is x squared. Once we get x squared, we can take the square root of both sides. So if we simplify, we have 64 out front, plus or minus, we have 64 squared, which is 4,096. We have negative times negative, which is positive. 4 times 64, so 256. So 4,096 plus 256. 4,352. 4,352 over 64 times 2. So we can get this as a decimal. We can do 64 plus whatever that is, 4,352, take the square root of that. So that's the numerator divided by 128. So that's x squared. Let's keep 1.015388. 1.015388. Then if we do a minus, we have 64 minus 4,352 square root over 128. We're going to get negative something. What was it? 0.015. And it doesn't matter how many decimal places we keep, because to get x, we have to take the square root of both sides. If we take the square root of that, that's imaginary. So that one's not going to help us. Take the square root of both sides and we get x. We get plus or minus whatever the square root of that is. So 1.015388. The square root of that is 1.00. I'm not sure how many decimal places they want us to go. We can call that 1.008. So that's our two critical points, positive 1.008 and negative 1.008. Then we just need to use either the first or the second derivative test to see which one of these is a maximum, which one of these is a minimum. This is our first derivative, so you probably don't want to have to take the second derivative of that. So we can put in a variety of numbers. We think about a number line We have negative 1.008. We have 0. We have 1.008. Oops. If we come in here and put in a number like, say, negative 2, when we put in negative 2, that's a number that is over here to the left. The absolute value of that will be positive 2. Negative 2 squared is 4 minus 1, so 3. So on bottom, we have 1 divided by the absolute value of 2, so 2, times the square root of 3, and then we're going to subtract 8. So that's negative. If we put a 0 in, we run into a problem because a 0 gives us 0 on bottom, so that's undefined. So let's imagine if we put in a number close to 0 but that's negative, so like negative 0.001. So if we put in a test value of negative 0.001, then we have 1 over the absolute value of that, 0.001, times the result of taking negative 0.001, squaring it, subtracting 1. So that's the result. Is that? Do that correctly? Okay, because if we take the square root of that, that's invalid. So if we get to negative 1, we're also undefined at negative 1. If you put a negative 1 in here, negative 1 squared is 1. 1 minus 1 is 0. So we would actually need a number between negative 1.008 and negative 1 because we're undefined there. So we're actually going to be undefined, all of this stuff in the middle. We can't use any of that. So long story short, if we put in a test point in here, I imagine we're going to go positive. So this is going to be a minimum at that x value. We can do a test. For time's sake, we won't go all the way through it. But if we put a positive 0.001 in, you know what? Oh, that was that test phrase we didn't use. But if we put a number out here to the right, we would be negative. In here, we would be positive. So if we're going up, then down, this is going to be a max here. Those are the x values. To get the y values, we need to plug them into our function. Well, let's do that with one of them. And I'll leave the other one for you. So if our function is arc secant 8, is it 8x? Arc secant x minus 8x. If we have a particular x value, we plug it in. So if we put in 1.008, we need arc secant of 1.008 minus 8 times 1.008. Well, the biggest question is, how do we do that? We don't have an inverse secant button on our calculator, but what we do have is an inverse cosine. Remember the relationship between secant and cosine. This is the ratio here for secant. And the ratio for cosine is the reciprocal of the ratio for secant. So if we know this ratio, 1 over that is the ratio for cosine. So take our calculator, do 1 divided by 1.008. That's what that ratio is. We're doing inverse cosine, and we want to be in radians. So inverse cosine, that's that result. And we're subtracting the result of 8 times 1.008. This is 8 times that. That's how much we're taking away. So about negative 7.938. So x is 1.008. Y is about negative 7.938. We could do the same thing with the other x. So we saw this one is a max, and that one is a min.